हाँ बोलो आशीष।
Sir, I wanted to inform you that I have a meeting with some people regarding my project.
हम्म।
Excuse for this class.
क्या हुआ, आवाज नहीं आ रही, थोड़ा आवाज। एक मिनट,
Sir,
एक
I
मिनट
am
रुको, एक मिनट रुको।
sir.
हाँ आप बोलो।
Sir, I have a meeting with some people regarding a project that I'm working on. So,
हाँ हाँ,
can attendance be excused for this class?
एक मिनट। सॉरी, एसी की आवाज थी। हाँ आप बोलो। हाँ ठीक है, सॉरी। हाँ
Sir, I wanted to tell you that I have a meeting with some people I'm doing some project with.
हाँ हाँ।
So, can my attendance be excused for this lecture?
I mean, if you don't want to come, that is okay. I mean, what can I do actually? Yeah.
Sir, asking or asking for.
No, that's okay. If you don't want to attend, that's okay.
Yes, sir. Sir. Also, sir, could you share the recordings of the lectures that these weeks?
But you're not attending all the lectures?
Sir, I have some doubts from the previous lectures that I can't get the context of from my notes, so that's why I'm asking.
Mm-hmm. Yeah, so problem is that sharing, did I share it last time on YouTube or where?
Sir, you can share it on Google Drive. You can create a folder and you can all the.
I mean, the only problem is that they consumes a lot of space actually, and I think,
We
you
have
know, yeah.
we have limited space here at IT, so I can share. I can make a folder with that on Drive.
Yeah. So I think I need to check, and then I can share. I think I shared one video earlier, right?
Yes, sir.
Hmm. But I think, see, don't think like that, because the purpose is, of course, we are not meeting face to face. So you know that, okay, you can watch the recording video later on, and then so you don't attend the class, because what is happening actually, if there is no interaction, I don't know whether you will be able to do anything, because so one-sided learning or two-sided learning, there is a difference actually. So that you need to make sure. By the way, I think, did you finish the assignment?
Yes, sir. That question, that algorithm that you asked us.
No, yeah. So I've given you one assignment long time ago, right? Any progress on that?
So we're going through the paper. It's actually complex, so that's take.
With whom you are reading?
Sir, I'm
Hmm?
Praveen Pandey.
Okay. So up to what time you have finished or anything? I'm not sure actually. So maybe I need to put a mark, because you see, we have not taken the exam yet. So uh, because there are only 4 students, I can give you a take-home exam or something like that. But I guess, but you have to do something actually.
Yes, yes.
Anyway, fine. You go.
Thank you, sir.
Sir, regarding the last class question that you gave, I tried to solve it, and
Uh-huh.
sir, I uplifted for up to 3 cubes, and then I uplifted for five up to 5 square for
Mm-hmm.
modulus mod I think mod 5.
Mm-hmm.
So sir, after that I got uh, for 5 square I got only 18 as the root.
Okay. 18.
Yes, sir, 18. And for 3 square, I got, sorry, 3 cube, I got 0, 9, 18, 15, 2, and 26.
So
18,
what
15,
what is the
26.
final answer that you got?
Sir, after this step, I was not able to proceed further, so I stopped it.
Okay. Okay, so maybe I will, I will do it again, from where we left actually. So Komal is coming or not? I mean, I'm not sure.
Sir, before 5, 6 minutes, I meet her in the mess. Maybe she might be going to the lab and then opening her laptop, and that might taking some time.
Okay, sure. So you got your job or not yet?
Yes, sir.
You got your job? You got some job somewhere or no, not yet?
Sir, for the next in the next semester, the companies will be visiting. So for this semester, for us,
Okay.
no, there is no.
Okay, so all four of you will be taking placement from the institute.
Yes, sir. As institute as well as we will try for other stuff also. Whatever the benefits will go there.
Mm-hmm.
I think so Komal has joined.
Okay, yeah, Kumar. So I think who is missing? Ashish just now left. Who else is there?
Ajit,
Hmm?
Ajit, sir, Ajit, Ajit.
Ajit. He is not coming.
Komal can answer, sir.
Okay, so okay, I think Komal, maybe we can start actually, you know. You can see my screen.
Yes, so we can.
Okay, so I think I will just quickly recall what we have done last time. We looked at Chinese remainder theorem. If M1, M2, MT are pairwise co-prime numbers, that means their GCD is 1 between any two pair of primes. And if A1, A2, AT are arbitrary integers, then these T equations, x is congruent to A1 mod M1, x is congruent to A2 mod M2, dot 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 x is congruent to AT mod MT, are simultaneously solvable, and the solution is unique modulo product of mi's. So if small m is the product of mi's and small ni is capital M divided by mi, then we can compute ui, which is inverse of ni modulo mi. Okay, and so basically one can see that ni is co-prime to mi, and hence the solution x turns out to be summation I is equal to 1 to t ui ni and ai. So you can substitute and check. This is a solution which satisfies all the equations, you know. Here is an example. If x is 5 mod 7, 3 mod 11, and 2 mod 13, I know the values of ai, I know the values of mi's, small m as a product, then ui's as the inverse of the other elements, ni's, and then x is nothing but linear combination. So the answer is 509, right? Then, so Chinese remainder theorem we will be using in our next concept when we look at polynomial congruences, especially Hensel lifting. If you want to solve fx is congruent to 0 mod m, where the coefficient is zm, so m can be written as partial product of prime numbers. So if we know the roots of fx modulo pi raised to power ei, then we can find out the roots of fx modulo m using Chinese remainder theorem. So this is what we are going to use. Now, if you consider fx congruent to 0 mod p raised for e, Hensel lifting finds the solution of fx congruent to 0 mod p raised for epsilon plus 1 from the solution fx congruent to 0 mod p raised for epsilon, right? So from this we can find the solution here, and by a technique known as Hensel uplifting. So what we do, xi with the root, suppose xi is the root of fx congruent to 0 mod p raised to epsilon, so f of xi is equal to 0 mod p raised to epsilon, right? So all integers satisfying the equation modulo p raised to epsilon are xi plus k times p raised to epsilon, right? Xi is the root of the equation, and so all others will be this, because modulo p raised to epsilon, this right portion will be 0. So or multiples of p raised to epsilon plus xi will be a solution of this, right? So we need to check for what k these roots are remain solution of the equation modulo p raised to epsilon plus 1. Assuming fx is a polynomial in degree d and put x equal to xi plus k times p raised to epsilon, we arrive at this expression. And then if we take modulo p raised to epsilon plus 1, we got k times p raised to epsilon times f dash of xi is equal to xi is equal to minus fxi modulo p raised to epsilon 1. In other words, we have f dash of xi times k is equal to minus f of xi times p raised to epsilon modulo p. Okay. Now k is 0, 1 or p depending on the values of these two things. And since p raised to epsilon divides fxi, this is an integer quantity. Okay. Now, so we were doing this example. 2x cube minus 7x square plus 189 is equal to 0 mod 675. So fx is this expression, f dash of x is this expression, m is 3 cube into 5 square. So first I will find root over f modulo 3, then uplift we'll find up modulo 3 square, and then we'll find modulo 3 cube. Similarly, we will find modulo 5, and then what we'll find modulo 5 square. So solution of fx congruent to 0 mod 3, I can substitute the values of x equal to 0, 1, 2, and it turns out that 0 and 2 are the roots of the equation, modulo 3. Okay, now we will uplift the root one by one. When we uplift the root 0, so okay, so from the expression f0 by 3 is equal to 63 and f dash of 0 is equal to 0. So this equation is true for any value of k, which is 0, 1, 2. So lifted roots are, I can substitute the values 0, 3 and 6 modulo 9, because p is equal to 3, xi is equal to 0. Okay. For lifting the root x equal to 2 mod 3, I do the same calculations, similar calculations, and arrive at k is equal to 2, which is unique solution. So lifted roots are 2 plus 2 into 3, which is 8. So total roots are 8 from here and 0, 3, 6 from here, right? So modulo 9, we got roots are 0, 3, 6, 8. Okay.
Yes.
Now, yes. So now we have roots modulo 9. Now if you look at, so I need to look at solution of fx congruent to 0 mod 3 cube. Okay. Okay. So first we are going to lift these roots 0, 3, 6, 8 one by one. Lift the root x multiple of 0 mod 3 square. Okay. So f0 divided by 3 square turns out to be 189 divided by 9 is equal to 21, and f dash of 0 is equal to 0. You can substitute these things. So we have f dash of 0 times k is equal to minus f of 0 divided by 3 square mod 3. Now this is satisfied for k is equal to 0, 1 and 2. Okay, so that means lifted roots are epsilon plus kp, if you remember. So epsilon is xi is 0, k is equal to 0, 1, 2 and p is equal to 3. Right, so the roots are 0, 9 and 18. Okay.
सर इसमें मॉड थ्री होगा या मॉड नाइन नहीं होगा मॉड थ्री स्क्वायर तो
हाँ
एप्सिलॉन सर जो एफ डैश ऑफ जीरो इंटू के इक्वल टू माइनस एफ ऑफ जीरो बाय थ्री स्क्वायर हमने लिखा है
हाँ,
और उसके बाद वैल्यू
यहाँ पे तो एप्सिलॉन नहीं रहता है ना. इफ लुक एट द इक्वेशन, एक्चुअली look at the equation here. See, this is mod p only.
पी रेज़ टू द पावर एप्सिलॉन से हम डिवाइड करते हैं मॉड अच्छा मॉड पी ही रहता
हाँ, mod p रहता है. p रेज़ पर एप्सिलॉन से दोनों तरफ डिवाइड कर देते हैं ना.
है राइट.
So the lifted roots are 0, 9 and 18. Okay. Now we lift the another root. Lift the root x is congruent to 3 mod 3 square. Okay, again we do the calculations. F3 divided by 3 square turns out to be 20. I'm not doing the all calculations. Similarly, f dash of 3 turns out to be 6 into 9 minus 14 into 3 turns out to be 12. Okay, so we have the equation f dash of 3 times k is equal to minus f3 divided by 3 square mod 3. It turns out that this has no solution, that you can check. It has no solution, okay, for any k. Therefore, root x equal to 3 does not lift. So this is also a possibility. Sometime a root does not lift, okay, to a root modulo 3 cube. Okay, next we look at root x is congruent to 6 mod 9. Okay, so when we have x is equal to 6 mod 9, so I can compute f6 divided by 3 square turns out to be 2 into 216 minus 7 into 36 plus 189 divided by 9. This turns out to be 48 minus 28 plus 21 is equal to 41, and f dash of 6 turns out to be 216 minus 84 is equal to 132. So again, there is no solution for the equation f dash of 6 divided by f dash of 6 times k is equal to minus f of 6 divided by 3 square mod 3. You can check that there is no solution for k. Therefore, root x equal to 6 does not lift. Okay. Finally, we consider root x is equal to 8 mod 3 square. So we compute f8 divided by 3 square turns out to be 765 divided by 9 is equal to 85, and f dash of 8 is equal to 6 into 64 minus 14 into 8 is equal to 272. So we have equation f dash of 8 times k is equal to minus f of 8 divided by 3 square mod 3. So when we solve this for k, this gives us 272 times k is equal to minus 85 mod 3. This implies that k is equal to 1 mod 3. In fact, from here you can see that 2k is congruent to 2 mod 3, and hence k is 1. This is a unique solution. So unique uplifted root is 8 plus 1 into 9, which is 17, xi plus k into p square. Okay, and so here, therefore all roots modulo 3 cube are 0, 9, 17 and 18. These are all roots. As you can check, 17 is from here. Yes. And from here 18 is there, right? 0 is there, 9 is there. Okay, so these are all the roots modulo 27. Now we look at the equation fx congruent to 0 mod 5. What happens to this? Because it was 3 cube into 5 square. So we put x equal to 0, 1, 2, 3 and 4. We find that f of x is 0 mod 5 only for x equal to 3 and 4. So solutions of fx congruent to 0 mod 5 is square. Okay, so we have two roots 3 and 4. I need to uplift them. So root x equal to 3 mod 5 will give rise to, so f of 3 time by 5 turns out to be 2 into 27 minus 7 into 9 plus 189 divided by 5 is equal to 180 divided by 5 is equal to 36. And f dash of 3 turns out to be 6 into 9 minus 14 into 3 is equal to 12. So therefore f dash of 3 times k is equal to minus f3 divided by 5 mod 5. This equation has a solution. I mean, this gives you 2k is congruent to minus 1 mod 5. Okay, therefore k is equal to 2 mod 5. It's a unique solution, therefore unique lifted root 3 plus 2 into 5 is equal to 13. So this root 3 is lifted here. Root 3 is we are able to lift. Now look at the 4. For x is congruent to 4 mod 5, f of 4 divided by 5 is equal to 2 plus 64 minus 7 into 16 plus 189 divided by 5 turns out to be 205 divided by 5 is equal to 41, and f dash of 4 times k is equal to minus f of 4 divided by 5 modulo 5. So this gives us the solution 40k congruent to minus 41 mod 5. Now this does not has a solution. Therefore, so there is no solution. Therefore, x equal to 4 does not lift. Therefore, the only solution of fx congruent to 0 mod 5 square is x congruent to 13 mod 25. Okay, so x equal to 13 is the solution because this is the lifted root as you saw here. So now we are ready. We combine the solution for 3 cube and 5 square. So we combine the solutions for 3 cube and 5 square. So the solution of fx congruent to 0 mod 675. Okay, so this number is 27 as you know, and this number is 25. Okay, so we combine the solutions using CRT. Since inverse of 25 is 13 mod 27 and inverse of 27 is also 13 mod 25. Therefore, all the solutions of fx congruent to 0 mod 675 are from Chinese remainder theorem 25 into 13 into 9 plus 27. Sorry, this is not 9, A. 27 into 13 into B modulo 675 for A in the set 0, 9, 17, 18. These are the lifted root in the first case, and for B in 13. This is the only lifted root in the second case. Therefore, solutions are x congruent to 63, 288, 513, 638 mod 675. Okay, so this is how we solve the congruence. So any question at this point? Okay, any question?
No, no, sir.
Okay. Okay, so now I think I would like to start another topic known as quadratic congruences. Asha, by the way, I want to ask you the primality testing, you know?
सर यू हैव हर्ड अबाउट इट, मतलब डिटेल में नहीं पता सर बस।
अच्छा, कोर्स का जो सिलेबस है वो तो मालूम है ना, कि वो भी नहीं मालूम है? वो थोड़ा बहुत मालूम है, थोड़ा सा देखा होगा जो आपने पहले लिखा था, राइट?
हाँ सर, जितना आपने कहा था बस उतना ही सर।
ओके, तो कोर्स का कैसा लग रहा है? मतलब आई जस्ट वांट टू गेट योर फीडबैक बिकॉज दिस इज ऑल मैथमेटिकल वी आर टॉकिंग अबाउट, राइट? एंड how do you feel about it? Is it worth studying this course or not?
तो बिल्कुल वर्थ है सर, बस वही है कि मतलब फेस टू फेस इंटरेक्शन नहीं हो पा रहा है, और कोई दिक्कत नहीं है।
फेस टू फेस ना?
हाँ मतलब उसमें और ज़्यादा बेटर हो जाता, मतलब मतलब मैं मेरा पर्सनली बोल रहा हूँ सर, मतलब अगर मैथमेटिक्स बोर्ड पे होता तो।
हाँ वो तो, that is, I know that is a problem. I
हाँ
also
जी
want to
सर।
see your faces so that I can see whether you are following it or you are not following it, otherwise there is a difficulty in doing these things anyway. So एक्चुअली मैं एग्जाम भी रखना चाह रहा था, तो कब एग्जाम रखें हम लोग? क्योंकि अभी तो तुम लोगों का फर्स्ट मिड सम तो हो गया ना अभी। Do you want to have a objective exam or do you want to have a I give you take home exam and you give it as a take home and solve it and give it back to me? What do you prefer actually?
सर टेक होम।
Hmm, एक मिनट, कौन बोल रहा है ये मैं देख लूं।
सर अजीत।
अजीत, अच्छा अजीत is there. Okay. What about Komal and Praveen? You want a take home exam or do you want
Sir,
exam or you want actually, there is also another possibility that I give you, I can grade you based on maybe readings, like I have given you one paper, so that assignment, because it's a PG course, right? So basically we are flexible. We don't want like undergraduate things, we keep on giving you exams and so on, it's the purpose is to learn, and so maybe senior level you can we can give you some other papers to read and the comment, or maybe you can present a paper, something like that is also possible. So whatever is good for you. Yes, Komal, you were saying something. Yeah.
yes, sir. You can give a paper or you can give assignment also.
So एक असाइनमेंट जो दिया है उसका डेडलाइन कब रखे हैं अभी हम लोग, बताओ? आई थिंक टाइम हो गया ना उसको दिए हुए, 1 महीना होने वाला है शायद.
Yes, sir.
सो शुड वी पुट ए डेडलाइन? बिकॉज डेडलाइन नहीं रखेंगे तो ऐसे ही चलता रहेगा. टुडे इज ओके, फ्राइडे ना? So should we put it on Wednesday तक, right? A deadline for submitting, that assignment, one that I have given to you.
Okay, sir.
Okay, so I think on the Google Classroom, I think I will open, or I think if you want, you can submit on the WhatsApp also. I mean, anything is fine. I can grade, I can make a list, whatever you want actually. WhatsApp is a fast communication, so that is there. Yeah, 1 minute. हाँ, इनमें से कोई है क्या?
सर
हम्म.
सर मैं पूछ रहा हूँ बस, असाइनमेंट से काम नहीं चलेगा, प्रेजेंटेशन भी देना पड़ेगा क्या?
तो असाइनमेंट तो अभी तो दिया ही नहीं ना तुम लोगों ने, इसलिए तो मैं पूछ रहा हूँ. असाइनमेंट सबमिट करो तो तब तो कुछ पता लगे. असाइनमेंट अगर सबमिट तो करो पहले, तो फिर दूसरा असाइनमेंट दे, क्योंकि कुछ 3-4 असाइनमेंट तो होने चाहिए ना, एक ही असाइनमेंट से कैसे काम चलेगा?
हाँ जी सर, हाँ जी सर।
तो ठीक है, एक काम करते हैं, ये वेटनेसडे तक आप लोग सबमिट कर दो, ठीक है ना, क्लास से पहले.
डन सर।
ठीक है ना? तो जब तक डेडलाइन नहीं होगी तो काम होता नहीं है एक्चुअली. ठीक है. सो लेट अस डू दैट. एंड are you reading any book also? Another question I want to ask you. Hmm? Are you
मैं
reading
तो नहीं
any?
पढ़ रहा हूँ सर।
अच्छा,
बाकी का नहीं मालूम।
ये अजीत बोल रहे हैं ना? ओके, so what I'm saying that see, I wanted to uh, of course the time is very less, because how many lectures are left actually? Any idea how many lectures are left?
सर अराउंड 8 आई गेस।
बस?
हाँ सर। सर अपना ये अप्रैल एंड तक तो ख़त्म हो जाएगा कोर्स अपना। और सर ऑलमोस्ट अराउंड 8 वीक्स ही है, मतलब सर सॉरी 6 वीक्स है सर।
तो 6 वीक्स में तो 12 लेक्चर हुए ना, 8 कैसे रह गए? 2 पर वीक नहीं है? बीच में छुट्टी है क्या?
Yes, yes, sir.
ओके, तो एक्चुअली कोर्स बहुत स्लो चल रहा है एक्चुअली, आई एम नॉट श्योर। So basically, okay, I think so. I think I have covered till now the basic things for you. The background building हो गया है. Now we can go to the some of the main algorithms. But of course, there are many things. But by the way, have you seen any of this stuff? Whatever we have covered, you already know about these things, or in the algorithm course or anything?
Oh, yes, sir.
Uh, which course? So how most of the material you know, like the Hansel uplifting to whatever today I taught.
No, no, sir. ये वाला टॉपिक नहीं पढ़ा जो आपने अभी ये क्लास में बताया।
Okay.
सर जैसे प्राइमरी टेस्टिंग सब पढ़ा है हम लोगों ने, एंड देन मल्टीप्लिकेशन पढ़ा था काफी
प्राइमरी टेस्टिंग में कौन कौन सी एल्गोरिथम पढ़ी है? एक से टेस्टिंग पढ़ा हुआ है?
ये सर पढ़ा था
कोर्स में पढ़ाया है उन्होंने?
सर।
एल्गोरिथम का कोर्स?
एल्गो ये सर।
अच्छा, क्योंकि उसमें एक्चुअली उससे पहले भी काफी सारे डेवलपमेंट हुए हैं, सो यू नो if you cover that and go to the primary AKS primary testing, it will take a lot more lectures, so I need to see how to plan it. Anyway, I think let me think about it, how we can plan. Okay, so
सर आप क्या वो मतलब पोलर रो पोलर एल्गोरिथम्स ये सब पढ़ाने वाले हैं क्या?
हाँ, मैं वही सोच रहा था, पर तुम लोगों ने अगर पढ़ा है कि नहीं पढ़ा है वो मेरे को मालूम नहीं है एक्चुअली, दैट इज बिकॉज यू नो फर्स्ट टाइम आई एम टीचिंग इन दिस एमटेक प्रोग्राम, यू नो, so I'm not sure what is your background actually, because I have never met, you know, so have you read those things or nahi?
हाँ सर, मतलब पढ़ा है सर, मतलब जो पुराने पुराने एल्गोरिथम्स है, सीव नंबर सीव एल्गोरिथम्स, ये सब तो पढ़ा है सर।
इलिप्टिक और वाले सारे पढ़े?
सर इलेक्टिव को वाले नहीं पढ़ा है, सारे
तो
सर सारे नहीं पढ़े उसके सर।
तो should I cover elliptic or algorithms for it? Should we cover that? I mean,
हाँ
accordingly,
जी
see,
सर।
whatever you don't know, na, I can pick up that rather than, you know, covering which already you know, you know. So अभी तक क्या था ना, it was a kind of basic material. Whatever I thought, it is basic thing which you should know. So if you know most of the topics here, so I think it's repetition anyway. But I think we have built with most of the basic stuff, you know. So I can go to then you know, इलेक्ट्रिक और सिस्टम एंड सो ऑन। बाय द वे, पेरी जीपी में ट्राई किया कुछ नहीं?
सर थोड़ा बहुत किया है सर।
ओके
सर
ओके
अब
सो आई
इलेक्टिव को पढ़ा सकते हैं सर,
ओके ठीक
अगर
है।
अभी।
ओके, सो मैं आई थिंक अभी एक काम करता हूँ, आज आपको थोड़ा सा एक और बेसिक चीज़ है जो कवर कर देता हूँ, दैट इज यस। ठीक ठीक। ओके, सो आई थिंक लेट मी स्टार्ट। इसमें I think you might have read most of the things, quadratic congruences. So we are looking at the equation ax square plus bx plus c is congruent to 0 mod m. Okay. Suppose m is a prime number and suppose it's an odd prime, it's not an even prime. Assume that p does not divide a, then 2a is invertible mod p. Okay, so then we can write down this whole equation as y square is congruent to alpha mod p, where y is x plus b times 2a inverse mod p, and alpha mod p. Alpha is b square minus 4ac times 4a square inverse mod p. Okay, so this you can simplify, you can just substitute it back and you can see that you will get ax square plus b plus c. So this tells us that we should focus, if we want to solve the quadratic congruences, it is sufficient to focus on these kind of equations. Okay, so we are left with these kind of equations, a mod p. So now we are going to talk about quadratic residues. Have you heard of quadratic residues before? Yes, any idea about quadratic residues?
No, sir.
Okay, so you should think about quadratic residues. Most of the work was done by Gauss, Carl Friedrich Gauss, in his famous book. He has written many results. So actually, it is said that mathematics is the queen of all science, and number theory is the crown actually on the queen, right? And quadratic residues are gems on the crown actually. So they are so important, that very important in number theory. So I will cover some of the basic things about them. So we start with the a odd prime, okay, and so an integer a such that GCD of a and p is 1 is called quadratic residue mod p if equation x square is congruent to a mod p has a solution. So basically, if this equation has a solution, then integer a is known as quadratic residue, because we are reducing this. Quadratic means we are taking the square and reducing it to a. Whatever a is coming, we'll call it as a quadratic residue. If a is an integer with GCD of a and p is 1, is called quadratic non-residue if the equation does not have a solution. Okay, so that is a quadratic non-residue. Let us take an example and it will be very clear to you. Suppose p is equal to 5, odd prime. So we start with 1. 1 square is 1 mod 5, which is fine. 2 square is 4 mod 5. 3 square is 4 mod 5. And 4 square is 1 mod 5. 4 square is 16, mod 5 is 1, right? So you can see that when we have the number 1, 2, 3 up to p minus 1, half of them are quadratic residues and half of them are quadratic non-residues. You can see that here. So 1 and 4 are quartic residues. So I can write down quartic residue set is 1 and 4, and quartic non-residue set is 3 and 5. Okay, modulo 5, p is equal to 5. So in general, p minus 1 by 2 quartic residues are there, and p minus 1 by 2 quartic non-residues are there. This is a very basic fact. Okay. Okay, so now I define a characteristic function known as Legendre function. Okay, if p is an odd prime, and a is not divisible by p, then Legendre function a by p is 1 if a is quartic residue mod p, and minus 1 if a is quadratic non-residue mod p. Okay, so sometime we write a by p is equal to 0 if a is divisible by p. Okay, now there are certain properties of Legendre function, so it's a characteristic function. So basically, if bunch of numbers are there, I can check whether that if the number is quartic residue, I will drop 1. If it's a number is quartic non-residue, I will drop minus 1. So for example, from 1, 2, 3, 4, for p is equal to 5, so 1 is a quartic residue, so the characteristic function will be, this function will give you 1, and 4 will also give you 1, but 2 and 3 it will give you minus 1. Okay, so there are now certain properties of this function. First property, if a is congruent to b mod p, then a by p is same thing as, the characteristic of a mod p is same thing as characteristic of b mod p. Same hoga because a and b are okay, is same. Second property, says that a by p same thing as a remainder p by p. Third property, I think these are easy to prove, I'm not proving any of them. AB by P is same thing as A by P times B by P. Fourth, 0 by P is 0, 1 by P is 1, and A square by P is 1 if GCD of A and P is 1. Fifth, minus 1 is quartic residue. So minus 1 by P is minus 1 raised to power P minus 1 by 2. This implies that minus 1 by P is 1 if and only if P is of the form 1 mod 4. 4k plus 1 prime is of the form 4k plus 1. Sixth property, 2 by P is equal to minus 1 raised to power P square minus 1 by 8. These are the very good formulas to compute these values. So 2 by P is 1 if and only if P P is of the form plus minus mod 8. Okay, then we have Euler's criteria. This is also quite useful. P is an odd prime and A is an integer. Then A by P is same thing as A raised to power P minus 1 by 2 mod P. Okay, so I think maybe skip the proof and we go to the next symbol, which is known as, so note that here A by P means P is a prime number. So what if I want to generalize it to A by B, where B is product of prime? So can we have a formula? So the answer is yes, and that is known as Jacobi symbol. So B is an odd positive integer such that I can assume that B is of the form P1, P2, PR, where odd primes PIs are not necessarily distinct. So the Jacobi symbol A by B is nothing but partial product I is equal to 1 to R A by P raised to power Pi, A by Pi, which is nothing but Legendre symbol. So including the case Pi divides A. So now there are some properties of Jacobi symbol for odd positive integers P and B prime, and for any integers A and A prime, we have first property A prime by B. Jacobi symbol is same thing as A by B times A prime by B. Just like that, the Legendre symbol, we have this result. Second, A by BB prime is same thing as A by B times A by B prime. Okay. Third property, if A is congruent to A prime mod B actually, then A by B Jacobi symbol is same thing as A prime by B. Okay. Fourth, A by B is equal to A remainder B mod B. Okay. Fifth, A by B, sorry, I think fifth is for -1 actually. Yes. -1 by B, same thing as minus 1 raised to power b minus 1 by 2. Sixth property, 2 by b is same thing as minus 1 raised to power b square minus 1 by 8. Seventh is a very important property known as law of quadratic reciprocity, and this law was given by Gauss. It's very important one. It says that b by b prime same thing as minus 1 raised to power b minus 1 b prime minus 1 by 4 b prime by b. So we are just reversing. You see that here b by b prime goes to b prime by b. Okay. So basically, let me actually. So a specific case of this is if P and Q are odd primes, then P by Q is same thing as minus 1 raised to power P minus 1 Q minus 1 by 4 Q by P. Okay, so let us use these to calculate some values by in an example. So example, what is the value of 51 divided by 541? Question is this. So 51 divided by 541 can be written as 3 divided by 541 and 17 by 541, because 17 into 3 is equal to 51. So use, and we are using the product factorization. Now this value is nothing but minus 1 raised to power law of quadratic reciprocity 3 minus 1 541 minus 1 by 4 541 by 3 minus 1 raised to power 17 minus 1 541 minus 1 divided by 4 541 by 17. So whenever actually you see here the denominator is something like bigger, we reverse it. Okay, and so we simplify this. This turns out to be 541 by 3 into 541 by 17. So everything is reversed now. So here it was 3 by 541, 17 by 541. Now it is 541 by 3 and 541 by 17. Now this is nothing but 1 by 3, 14 by 17. Okay. So check from which law we are getting this. I leave it as an exercise for you. This is nothing but 14 by 17 because I have applied 1 by 3 formula. 14 by 17, which is nothing but 2 by 17 into 7 by 17 is equal to minus 1 raised to power 17 is square minus 1 divided by 8. 7 by 17 is equal to 7 by 17 minus 1 raised to power 7 minus 1 17 minus 1 divided by 4 17 by 17. So this simplification is nothing but 17 by 17 equal to 3 by 7 is equal to minus 1 raised to power 3 minus 1, 7 minus 1 by 4, 7 by 3 is equal to, this whole thing is minus now, minus 7 by 3 is equal to minus 1 by 3. Okay, minus 1 raised to power 3 minus 1, 7 minus 1 by 4, 7 by 3. One minute. 3 by 7 is 7 by 3. Okay, sorry, this is, yeah, yeah, this will be minus 1 actually, yeah, because this is, yeah, I think I have written wrong. I'm sorry. This value will be minus 1, yeah. Therefore, we computed that 51 is a quadratic non-residue mod 541, right? So we can compute this. Now actually the same thing can be computed. So here we have used prime business, you know, if you look at, we have used prime business, but without prime business, we can do it a little bit faster actually. Okay, so let me do that calculation for you. Example, compute. So another way of doing it, 51 by 41. So 51 by 541 is nothing but minus 1 raised to power 51 minus 1, 541 minus 1 divided by 4 times 541 divided by 51 is equal to 31 divided by 51. The remainder thing is equal to minus 1 raised to power 31 minus 1 times 51 minus 1 divided by 4 times 51 divided by 31, and this minus sign is nothing but minus of 51 divided by 31 is equal to minus of 20 divided by 31. ये रिमाइंडर का फॉर्मूला लगाया हमने, ओके, is equal to minus 2 by 31 whole square into 5 by 31. ओके, पांचों को 20 ऊपर लगा दिया है, is equal to minus of 5 by 31 is equal to minus 1 raised to power 5 minus 1, 31 minus 1 divided by 4, 31 by 5 is nothing but minus of 31 by 5, which is nothing but remainder का formula लगाया, this is nothing but minus of 1 by 5 is equal to minus 1. Therefore 51 is a quadratic non-residue mod 541. The same thing but with different calculations. Okay, so I think that's all for today. Okay, so we have done some calculations for these Legendre symbol and Jacobi symbol. Jacobi symbol in the denominator there is only p prime. In sorry, the Legendre symbol there is a prime p in the denominator, and in the Jacobi symbol it's a product of prime numbers. We can use that. So this is fine. Now I think our background is done. We will try to do few more new things now. Okay, in our next classes. Thank you.
Thank you, sir.
Thank you, sir.
Hello, sir.
हाँ बोलो बोलो.
Sir, regarding the AKS algorithm for parametric testing, कि मुझे कोई algorithm वगैरह समझनी थी. तो if you आपके पास कोई free time होगा जिसमें मतलब मैं मीटिंग वगैरह शेड्यूल कर सकूं?
हाँ हाँ, तो मैं एक्चुअली सी अगर तुम लोगों ने एल्गोरिथम नहीं पढ़ी है तो हम उसको कवर कर दें, और अगर पढ़ ली है तो फिर देयर इज नो पॉइंट. तो मैं एक काम करता हूँ एक्चुअली, लेट मी लुक एट द एंटायर सिलेबस, और you know there are as I mentioned there are some books. I don't know, but अगर आप बुक पढ़ नहीं रहे होगे तो फिर then I think there is a gap, right? There are some good books as well. तो लेट मी, अदरवाइज वी विल कवर एक्चुअली, ठीक है ना. मे बी आई विल जस्ट लुक एट द एकेएस प्राइमरी टेस्टिंग, अगर बाकी सारी नहीं पढ़नी है तो ठीक है ना. आई विल लुक एट इट, ठीक है ना. मैं अभी थोड़ा सा अनुमान लगा लूँ कि आप बोल रहे हो कि करीब 6 वीक्स है, राइट? 12 लेक्चर्स हैं, 8 लेक्चर्स हैं, राइट?
ये सर अजीत ने बताया, मैंने तो देखा नहीं एक्चुअली.
हाँ
हाँ सर, मतलब 8 या 10 होने चाहिए सर, मतलब जितना मैंने
10,
अनुमान लगा.
अगर 10 है तो फिर हमको 10 के हिसाब से देखना पड़ेगा अभी क्या क्या टॉपिक कवर करेंगे, सो दैट द एटलीस्ट बेसिक कोर्स कवर हो जाए ना, ठीक है ना. तो लेट मी थिंक ओवर इट कि कौन कौन से टॉपिक्स कवर करेंगे, फिर मैं कवर कर देता हूँ क्विकली. आई विल, बिकॉज अभी बैकग्राउंड का मटेरियल हो गया है. सो नाउ वी कैन गो टू द पोलाइमल कांग्रेसेस इंपॉर्टेंट था, ठीक है ना. नाउ वी कैन गो इनटू द एक्चुअल एल्गोरिथम्स, ठीक है. सो we will do it, let me look at the syllabus again just to make sure that what can be covered within the given amount of time. अगर तुम लोग एक्स्ट्रा क्लासेस के लिए रेडी हो तो हम बाद में ले सकते हैं एक्चुअली. इट्स अप टू यू एक्चुअली, ठीक है.
Yes, sir, I am ready. For regarding AKS, time in P regarding
ठीक
this
है, ठीक है,
paper
ठीक
that as the IIT Kanpur faculty that you told in the first class,
है. या
Manindra
मनिंदर
Nikhil,
अग्रवाल, या
regarding that. Yes.
yeah, sure, we will cover that. It's a very beautiful paper actually. It's not very big as well, just 6-page algorithm, and depending on one very important result obtained by Maninder Agarwal and Somnath Viswas, using that result, it's very straightforward. So let me talk about it. Okay. So, bye.